Good morning, everyone. Today we are going to discuss about Earth's movement, like seismicity, folding, faulting, and volcanicity. Okay. The Earth's crust is a dynamic state where immense unseen internal forces are constantly at play. These geological processes shape the surface and structure of our planet. Seismicity, folding, faulting, and volcanicity are the primary manifestation of this internal energy. Okay, first of all, seismicity. Seismicity refers to the occurrence and distribution and magnitude of earthquakes in a particular region. Earthquakes are the result of the sudden release of energy in the Earth's crust, leading to the propagation of seismic waves that can cause the ground to shake. That is earthquake. Now, there are three types of waves of during seismic activities like earthquakes. First of all, primary P waves, secondary S waves, and surface waves. Primary waves are the fastest seismic waves. They travel through both solid and liquid material. Then secondary waves, slower than P waves, they can travel only through solids. Surface waves traveling along the Earth's surface. These waves are responsible for most of the damage during an earthquake. Then there are some determinants of earthquake. Okay, first of all, magnitude. A measure of the energy released by an earthquake determined by seismographs. Depth of focus, distance below the Earth's surface where the earthquake originates. Local geology, the type of geological material through which seismic waves travel affecting amplification and shaking. Then distance from epicenter, proximity to the point on the Earth's surface directly above the earthquake's origin. Okay, these are some determinants of earthquake. Secondly, coming to folding. Folding is a tectonic process resulting in the bending or deformation of rock layers under compressional forces. It commonly occurs where tectonic plates collide, leading to the formation of fold mountains and other geological features. Okay, a visual glossary of fold structures: anticline. This is anticline. Syncline. This is syncline. U-shaped valley. Monocline. This is monocline. Okay, anticline, an upward arcing fold where the oldest rock layers are at the core. And then syncline, a downward throw-like fold where the youngest rock layers are at the core. Monocline, a steep bend or flexure in rock layers, often forming a steep-like structure. Then the conditions for folding: tectonic forces, confining pressure, temperature, and rock type. Okay, tectonic forces, compression forces from the plate movements exerted over geological time scales. Confining pressure, pressure from overlying rock layers can influence the folding behavior of underlying strata. Rock type, different types of rock respond differently to stress, influencing the folding pattern. Ductile rocks bend, brittle rocks fracture. Temperature, high temperatures can make rocks more ductile, allowing them to bend without fracturing. Then coming to our third topics, faulting. Faulting is the pressure of fracturing and displacement along geological faults, which are zones of weakness in the Earth's crust. It occurs due to tectonic forces and can result in landforms such as fault scarps and reef valleys. This is normal fault. This is reverse fault between face towards each other, and stack slip fault. This is transformed boundary. Normal fault occurs when the hanging wall moves downward relative to the footwall, downward. Okay, reverse fault involves the hanging wall moving upward relative to the footwall, upward movement. This is downward, this is upward movement. Then stack slip fault, horizontal movement along the fall plane with minimal vertical displacement. Okay, these are three types of fault: normal, reverse, and stack slip fault. In normal fault, they are downward movement. In reverse fault, they are upward movement and vertical displacement in stack slip fault. Then coming to the volcanicity. Volcanicity refers to the processes associated with volcanic activity, including the eruption of magma, the formation of volcanic landforms, and the release of gases. It occurs primarily at tectonic plate boundaries and hotspots where molten rock magma from the Earth's mantle reaches the surface. A visual typology of volcanoes. Okay, seal volcano, stratovolcano, that is composite, and cinder cone. Broad, gently sloping volcanoes characterized by fluid lava flows and non-explosive eruptions. These are seal volcano. Then stratovolcano, steep-sided volcanoes. That's why it's known as composite volcano, and built by alternating layers of lava, ash, and volcanic rocks. Then cinder cone, small steep-sided volcanoes formed from ejected volcanic materials around a central band. Okay, the four manifestations are not isolated phenomena. They are interconnected expression of tectonic forces often occurring together in geological active zones: folding, faulting, volcanicity, and seismicity. Okay, these all processes are important to understand. These processes is critical for assessing natural hazards and developing strategies to mitigate the risks of earthquakes and volcanic eruptions. They are important for hazard and mitigation management. Then landscape creation, the mountains, valleys, islands, and coastlines that define our world are the direct tangible results of these immense and ongoing forces. That are faulting, seismicity, and volcanicity. Resource formation, geological activity always plays a vital role in creating and concentrating valuable resources from mineral deposits along fault lines to geothermal energy in volcanic region. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.